what we're looking for is if I can do this thing or that thing. If you remember back from your homework, when we had the chart on the back where you had the different colored stones that are in the bag, and we were looking for red or blue or white, well, what we did was we added up how many red, white, and blues there were and put them out of the total number. If it was not yellow or red, we added those up and put it over the total number. So when we're dealing with or statements, we need to think about them as either inclusive events or mutually exclusive events. And the reason being is there are two different formulas that you use for either type of event. So we need to wrap our brains around what it is for something to be inclusive or what it means for something to be mutually exclusive.
Why can't it just be exclusive?
Because there are things in life that are not all exclusive. There are some things in life that are inclusive.
Yeah, but why does it have to be mutually?
So, inclusive events are events that can occur at the same time. For example, think about a deck of cards. What's the probability of getting a queen? 1 out of 13. Good. What's the probability of getting a heart?
1 out of 4.
It is 1/4, right?
What?
Because hearts are a whole entire suit. There's 4 suits. So if I said, Avery, if I said, what's the probability of getting a queen or a heart, can they be one of the same?
Yeah.
Isn't there a queen that is a heart?
Yeah.
So if I added up all the hearts probabilities, so that 1/4, and I added it to the queen probability, which is 1/13, and I added them, that queen's being double counted. Because it's being counted under the hearts and it's being counted under the queens. So I'm counting it twice. So that would be an inclusive event, something that occurs at the same time. So you need to think about it. Well, does this occur in this event and this event, or are they separate of each other? Mutually exclusive events are our favorite, because we don't have to think so much, are events that cannot occur at the same time. Hence, if I flip a coin, I can either get heads or tails. If I roll a die, I can either get 1 through 6. Can I get a heads or tails on a die? No.
Some types of dyes.
I don't think there are any out there with heads or tails on them. So those would be mutually exclusive. They can't occur at the same time. Okay? All right, so when we talk about addition of probability, the word or is going to be your standout word that's telling me that I need to add things together. So if we have the probability of A or B, so the first part's just mumbo jumbo to cover our topics of what it is we're talking about. If we let A and B represent events in the same sample space, now we've got 2 different formulas. If we have mutually exclusive events, that means they can't happen at the same time. If I've got a blue stone in a bag and I have a red stone in the bag, and I go to pull it out and I say, what's the probability of a blue or a red? The stone can't be blue and red at the same time, right? It's either blue or it's either red. It can't be both. So that would be a mutually exclusive event. Can't happen at the same time. So when you have that, if you're asking for the probability of A or B, you just take the probability of A and add it to the probability of B. Now, if you have inclusive events, like the Queen of Hearts getting double counted, you need to take that Queen of Hearts out. So if you had the probability of A or B, it's going to be equal to the probability of A plus the probability of B, but then you have to subtract where it becomes both. So if I make the diagram, so here we have Ace of Heart, queen of heart, or king, queen, jack, 10, 9, 8, 7, 6, 5, 4. My heart's getting worse. There we go. And then if we did our queens, I have a spade. I should have the girls that were sit up here. You guys were getting good at spade of queen, club queen, diamond of queen, heart of queen. Yeah?
Yeah.
Okay, so if I added these two together, we said this is 1/13 probability, this is a 1/4 or probability. If I had to add those together, I would get what? Common denominator is 13, 3, 12, 52 plus 1/13, so 53/13. Well, I counted the queen of hearts twice. So what do I need to do to that 5/3 13ths to get rid of it?
Minus it by
Subtract it.
4 and 3.
So I got to take that out. That's what we're going to be doing. So what's the probability that I have a queen and a heart? That it's a queen and a heart? It's 1 out of 52, right? So we would subtract that 1 out of 52 because I only have one queen of hearts out of the 52 cards. All right, we'll get that going here in an example. So here we got a survey. You don't have to write all this down. I would just maybe copy this table down so you have it. In a survey about change in public policy, we have 100 people who are asked if they are in favor of the change, oppose the change, or have no opinion about the change. What do we want it to be?
Elephants go in picket fence pen instead of the regular fence pen.
Okay, so we got elephants in a pen. You want it to be a picket fence instead of like a barbed wire fence?
Yeah.
Okay. So, if you are for it, you want the picket fence. If you're opposed, you want the barbed wire fence. If you're no opinion, you don't care what happens to the elephants. So, we have men, women, and the total. Got a favor, oppose, no opinion, and total. With the resulting numbers from the survey. Total of 100 people. We want to find the probability that a randomly selected respondent to the survey opposes or has no opinion about change in policy. Now, if I filled out that survey and I said, I oppose it, check, would I also check off the no opinion box?
Yes.
No, you wouldn't.
Yes, you would.
Well, you shouldn't
But you
do
would
that.
anyways.
You wouldn't. We don't have
Well, if you,
we don't have double votes going on here out of the 100 people.
Well, like sometimes.
Like if you count up all the in favor, all that oppose, and not all that are no opinion, they come out to be 100, which means people did not double vote.
If there was like a
If this-
middle, it would be opposed. It'd be like
Just
opposed.
think like
So, how many people, let's just focus on the problem, gentlemen. How many people opposed the change in the policy? 37 out of 100. How many people have no, gentlemen, how many people have no opinion?
36.
36 out of 100. And what are we going to do with those two? Add them. Now, there's nothing to subtract here because these are mutually exclusive events. I can't oppose and have no opinion at the same time. I only have one opinion. So we're going to add those together. And that gets us, what, 73 out of 100?
you.
Did I say 1,000?
Yeah, you did, but.
I meant 100.
We're just gonna go past it.
We'll roll with it.
Yeah.
Oh, I just looked at that, and it was 37, and I was like, that's
Is everybody okay with that?
Yeah.
All right, so what if we needed to find the probability that the survey is a man or opposes the change in policy? So the probability that it's a man, so let's write it out in probability notation. So probability of man or opposes What's the probability that it's a man that took the survey?
50 out
50 out
of 100.
of 100. I'm going to add to it. How many people opposed it?
37.
Now, is this mutually exclusive or inclusive events? Yeah, because can I be a man and oppose something at the same time? Yes. So we need to find how many men opposed the policy. 12. Okay? 12 out of 100. Because it's probability that you're a man and oppose would be 12 out of 100. We're not adding, we're subtracting that. Sorry. So what does that get us as a number? So 50 plus 37 is 87 minus 12, 75%. Yeah, 3/4. So we got a 75% chance that you're a man or you oppose those elephants and their picket fences. More people are against the picket fence, apparently.
That's awful. And it's mostly women.
All right. Last thing we have to cover is the complement, and we've already been talking about the complement. It just hasn't had a word to it yet. Remember on your homework, we had problems like if 73% of these people like this, then what's the probability that they don't like it? And we would just take it and subtract it from 100, or we'd subtract it from 1, depending on what we're given. Well, now we're going to put an actual word to it. That's called the complement. And there is a notation that gets used when we're talking about the complement. That A with like the superscript of C. So the complement of any event, in this case we're saying event A, consists of all the outcomes in the sample space that are not in A. So, if the probability of people who are for those elephants is 30%, what's the probability of those people who are not for the elephants? 70%. Okay? The probability of everyone in this room having the same birthday is 1%. What's the probability that we don't have the same birthday? 99%. I don't think it's that. It should be a little bit larger or smaller. Okay, so complement. We're just adding a word to everything that we've been talking about so far. And let's just go through this. Just want to watch this beautiful Venn diagram. We've got drama, mathematics, and jazz clubs. Have 32 members, 33 members, and 39 members respectively. Find the probability that a randomly selected club member belongs to at least 2 clubs. All right, so here we've got some overlap. Here we got mathematics club. There's 33 total members in math club. So 8 plus 10 plus 8 plus 7. How many people are in both mathematics and drama?
7 plus 8.
7 plus 8 would be in 15, right?
But you're also including jazz.
Right, but I'm just thinking mathematics and drama. How many people are in mathematics and jazz? 18. How many people are in jazz and drama? 19, right? How many people are just in jazz?
10 people.
How many people are just in drama?
6 people.
And how many people are just in mathematics?
8.
How many people are in all 3? 8. In the middle, right? Where the intersection of all 3 of them are. So what would be the probability that a randomly selected member belongs to at least 2 clubs? So how many people belong to at least 2 clubs? Well, here we have,
11.
so drama and math is, what do we say, 15? Math and jazz, we said, was 18, right? Drama and jazz is how many? 19. So that gets us a total of how many students? 36. Okay. Do we need to take rid of, do we have people being double booked in this case? Like, are we counting multiple people?
Yeah.
No.
Yeah.
Yeah, we are.
We are counting double people, right?
Yeah.
So really, what would we have to subtract from that?
Just a couple.
The amount,
Huh?
subtract 8.
If we subtract the 8, then that leaves us with just specific drama and mathematics from there, right? If we subtract the 8 from here, then we're just left with jazz and mathematics and nothing else.
No, and drama, 11. Wouldn't that be?
Well, if we subtract the 8 from drama and jazz, then we're just left with the individual 11, right? Okay. So really we're subtracting what from this? 24.
It's actually 52, by the way.
If I could add correctly. Yeah. 52. Who gave me 36? Did I make that up on my own?
That was a
Did I just listen to Avery and go with it?
Yes.
Is that the problem?
I don't give you random numbers.
I give you.
It's 52, Brandon?
Yes.
Okay, thank you. So that gets us
I even have it on my
8, 28. When we subtract 12. Or 24, I mean. Okay, so that gets us 28. Now, how many people are in 3 clubs? So it says at least 2. 8. So we can add that 8 back on to get to 36. Is that where we got the 36 from? Maybe he's just a genius and we don't know this. 36. How many total members are there? That's the hardest part. How many?
32, 33, 39.
How many total people are there?
52.
So
No, that's
be
just
careful. Your drama club
Can't
has
we count
same people of math.
There's only 24 people.
Is there only really 24 people, and we counted 36 that are in at least 2 clubs?
Well, everybody's in
Yeah, it's only
drama, math, or jazz. Maybe
All right, so let's do all of the drama. How many total drama do we have? 32?
Yeah.
Okay, so in drama, there's a total of 32. If we take out the drama people from math, that eliminates how many people? 15,
Yeah.
right? So if we take away 15 from 33, that would be 18. Now let's go down to jazz. From jazz, if we take out the people already counted by math, and we take out the people counted already from drama, we're left with just how many people left just in jazz?
Just a copy.
What number?
Just a copy. Like a handful of people.
What's left? 10, thank you. I didn't think it was that hard to see. So that gets us what? 50. Here we go.
Nope, 60.
The day's almost done. The day is almost done. All right. How is it? I'm